Hello and welcome. In today's video, I'm going to be teaching you how to implement authentication and authorization in NestJs framework. The authentication is a difficult topic, so please watch this video closely and to the end to fully understand the topic. As usual, you can find the GitHub link in the description of the video. So, without any further ado, let's get started. So far, we have implemented the 5 endpoints. They cover all of the CRUD operations. The goal of today's lesson will be to add users to the mix and allow for recipe creation and modification only to authenticated users. We will also introduce the user's role. There will be the user role and admin role. Only the admin will have the power to delete the recipes. To make our life easier and to not bore you with things you have already known, I have added a few lines of code since the last lesson. Let's reveal them now. Firstly, you may notice that there is a new module. I call it auth. It's casual NestJs module. It contains a controller, services, and so on. Inside the entity directory, there is users class. To keep it simple, it only contains 4 fields. There is email, password, role, and user recipes. That's the bare minimum. Next, I created the migration adding the users table. Inside it, you can see the table creation. The user's email must be unique, so I picked it as the primary key of the users table. Then I added the email to the recipe table and I created a foreign key. So now there is one-to-many relation between users and recipes. If you don't know the TypeORM migrations API, I created a video about it. You can check it here. Let's open the terminal now. Please type docker compose app to start the database. Next, in the new terminal window, type npm run migrations:run to run migration script. Now we have the database set and we are ready to move forward. Finally, let's take the closer look to the recipes controllers. For the post and patch methods, I added a request object as an input parameter. It's not implemented yet, but we will be able to access the users from the request object. Finally, I modified the recipe service. Now, when we create the recipe, it will be associated with specific user. That were all changes I did since the last lesson. Now, let's open the controller file from the auth module. Here, you can see the 3 methods: register, login, and refresh token. We have to implement those methods to create the authentication for our app. But you may ask, why only those 3? To answer this question, think about the idea of JSON web tokens. It's a stateless type of authentication. It means that the backend server doesn't keep any session state. The server only generates the JWT tokens and passes them to the client. Then, the client adds the authorization header to each protected request. Usually, the front-end side saves the tokens inside the local storage of the browser. So, to log out the user, the frontend only removes the data from the local storage. There is no need for any additional endpoint. Okay, let's start the implementation of the register method. This method has only one input parameter called register_DTO. The DTO class includes only 3 fields: email, password, and confirm password. It's also validated with usage of the class validator. In general, it's pretty simple stuff. To actually register a new user, we will call a register method from the auth service. Currently, it is not implemented yet. Firstly, the email has to be unique. Let's search for the user containing provided email address. If one is found, we cannot create a new account. In that case, we'll throw HTTP exception. And we will set the message to be equal email already registered. If there is no user with such email, we'll simply save the user to the database. But there is one thing we have to change. It's very bad practice to save plain text password directly in the database. Any attacker intercepting the database would have the full access to all accounts. To prevent that, it's a common practice to save hashed password inside the database. Saving hashes does the job because it's easy to create hash, but it's almost impossible to reverse the process. But you may ask, how we will check if user provided valid password? The hashing always works the same, so for the same password, we will get always the same hash. Instead of checking if passwords match, we will check if hashes match. To hash the password, we have to install additional packages. Let's open the terminal and type npm install save bcrypt. Then let's install the additional types. For that, type npm install save dev types/bcrypt. So now we can import the hash method from the bcrypt package. Let's create a new method and call it hashPassword. It will return promise string. The method will be quite simple. It returns the result of a hash function. The function gets the password as an input and then the salt number. Incorporating the salt is another level of protection. It protects before the rainbow tables attacks. Finally, let's invoke the hashPassword method inside the createUser method. And then let's change the plaintext password to the hashed one. Great, one of 3 methods done. Now let's dig into login functionality. Again, inside the controller file, we will only invoke the method from the service passing the DTO object. This time, the DTO contains only an email and the password. Let's open the auth service again. Firstly, I will search for specific user in the database. I will use findOne method of the repository. If none is found, I will throw an error. I will set the message to be equal invalid credentials. As I mentioned before, we won't compare the passwords. Instead, we will compare the hashes. To do so, I have to use another method from bcrypt package. This time, the method is called compare. The method is a promise. We have to await for the result. If the passwords don't match, I will throw the same error saying that credentials are invalid. It's a good practice to not give a hint what is incorrect, login or password. Somebody might try to brute force the login. Better to not give him any hints. Finally, if everything is okay with credentials, I will return the access token and refresh token. But to generate JWT tokens, as you may guess, we need another library. Inside the terminal window, please type npm install save NestJs/JWT. Because JWT package is a NestJs module, we have to register it inside the module we want to use it. Let's open the auth module file. Inside the imports array, please add JWT module.register method. The register method expects from us the configuration object, but I will pass here empty object. I will set required parameters in specific JWT methods. Moving back to auth service, I will add the JWT service to the constructor. It will be injected by a NestJs framework. I will also add a config service to the constructor parameters. It will be useful in a minute. So now, let's create a new private method called getTokens. I will pass there the user's object. We could save any payload inside the JWT token, but we have to be cautious. Anybody can decode this token. We should save there the data that may be exposed. Now, let's implement the getToken method. As an input, I will pass here the user object. Next, I will use the signAsync method of the JWT service. I have to pass 2 objects to the method. The first one is a payload, which will be saved, and the second one is configuration object. Inside the payload, there is a sub field. It's shorthand from a subject. Basically, it tells us for whom the token was issued. After the sub, I added a role property. It will be helpful in the near future, when we restrict the delete endpoint only for admin users. Then, in the settings object, we have to pass the secret key for the access token. I have added mine to the .env file. So here I'm using the config service. Remember, it's crucial to not leak this key when working with real apps. Finally, there is a setting of token expiration. This time should be possibly short. I set mine to be equal 15 minutes. Next, I will duplicate this code to create a refresh token. I will just change the environment variables. For the refresh token, I will use different key and longer expiration time. Finally, the signAsync method is a promise. I will wrap both method usage with a promise all call. I will await for the result and then assign the result to variables. After all, I will return the variables just to fulfill the interface. Now, we can use this method inside the login method. And basically that's it. Another service function done. Lastly, let's implement the logic for token refreshing. The controller will receive the body containing the refresh token. We will pass it to the service where the token will be verified, and if everything is okay, we will return new tokens. For refresh token verification, we will use the verifyAsync method of JWT service. This method takes as an input the token and the configuration object. Inside the configuration object, we have to specify the secret key for decoding the token. This method returns the payload or may throw an error if something is wrong with the token. We have to wrap it with the try and catch clause. I'm doing that because I'd like to return the same error from the method. No matter what went wrong, I will return a generic error saying invalid credentials. Remember, don't give any hints to the attacker. Next, I will search for the specific user using the find or throw method of the repository. The email address comes from our decoded token. Finally, if the token is valid and we have founded the user, we can return a new token. Let's simply return the result of the getTokens method. Cool, now we are ready to test all of those endpoints. For that, let's open the terminal and type npm run start :dev. This will start our server. For testing the API, I will use the VS Code extension called Thunder Client. The endpoint for registering the users is equal to auth/register. In the body section, I have to specify the email, password, and then I have to repeat the same password. When I click send button, there is 201 status created. Great. The endpoint for login is equal to auth/login. The body is slightly different, there is only an email and password. When I click the send button, I receive token and refresh token as a response. To check the endpoint for refreshing the tokens, I have to copy the refresh token first. Then I have to paste the refresh token to the body object and send it to the auth/refresh token endpoint. Again, when I click the send button, I get 2 tokens as the response. That's it, we have implemented all of the 3 methods from the auth service. That's great, but it's definitely not the end of the work. The next question you should ask is how we can actually use these tokens to prevent unauthorized access. Normally, in Express.js apps, we use the middlewares for checking if the client attached specific header to the request. In the NestJs app, the approach will be slightly different. We won't use middleware functions. Instead, the framework has entities called guards. The guard is a class that has to implement the canActivate interface. It has only one responsibility. It determines whenever a given request will be handled or not, depending on the certain conditions. The NestJs documentation encourages us to use the guards together with the passport library. The passportJs is a framework on its own. It abstracts a lot of stuff related to authorization. Okay, let's open a new terminal window to install required packages. For that, type npm install save nestjs/passport and passport-jwt. Beside those 2 packages, we also have to install types for the passportJwt. Now, let's type npm install save dev types/passportJwt. The NestJs passport library ships us the authGuard class. We will use this guard to protect the roads. But before so, the authGuard has to be connected with specific passport strategy. We can use the JWT strategy, OAuth strategy, Facebook login strategy, and so on. Let's start from creating a new access token strategy. I will create a new directory and I will call it passportstrategy. Then I will create a file called AccessToken.strategy.ts. The AccessToken strategy class will extend the passport strategy, which comes from NestJs/passport package. Then I have to pass the passport class and some unique name here. The name is crucial because we will use it to connect the strategy with the guard class. Our goal of creating a custom strategy is to provide the dynamic setup to it. Here in the constructor, I'm injecting the config service to access our secret key. Next, I have to call the super method. I set the secret key there. I also tell the framework from where it can take the tokens. In our case, it comes from the HTTP header. With that setup, the passportJs will grab the token from the authorization header and then it will validate it. Passport first validates the JWT signature and decodes the JSON. Then it will call the validate method from the class passing the parsed JSON. This method name is really unfortunate because it implicates that there should be some validation step, but this is only for additional validation. Our payload contains the subject and the role already. We will only return the payload from the method. By returning the payload, we will tell the passport to attach the request to the NestJs object. So, after calling the validate method, this specific payload will be available in the request object. Lastly, we have to register the strategy inside the modules providers array. Now we can connect the passport strategy with the auth guard. Let's create another directory and call it simply guard. Inside it, let's create the class called AccessToken guard. The guard will extend the auth guard from the NestJs passport package. Now, the most important part. We have to pass here the string matching our passport strategy. This way, we're giving auth guard instructions how to validate an incoming request. That's it, the guard is ready for usage. We don't have to register it in the module. It won't be injected anywhere. Instead, it will be simply imported. Now, let's open the recipe controllers file. We would like to protect the create recipe endpoint. For that, I will use another NestJs decorator. It's called useGuard. It will invoke the guard function we will specify. In our case, the guard function is called AccessToken guard. Now, let's open the Thunder client and let's try to create a new recipe. When I click the send button, recipe wasn't created. Instead, we got the error. That's correct behavior. To create the recipe, I have to set the authorization header. For the bearer token, I have to grab the access token received in the login endpoint. When the token is set correctly, we can create recipe without any errors. Let's move back to the controllers file. We have to protect the patch and the delete method as well. I will copy and paste the guards now. To meet all of the requirements, I will create one more guard class. This time, we will use the guard to check the user's role. Also, we will create custom decorator for that. We will use the decorator to set the metadata about required role. Let's start from creating the role decorator. Inside the auth directory, I will add the decorators directory and I will create the role.ts file. In this file, I will declare the role key variable. Then, I will create a role method. Basically, it will take the user's role and set it using the setMetadata function. The setMetadata function comes from NestJs/common package. Now, let's implement the authorization guard. For that, I will create authorization.guard.ts file. Then I will create class called roleGuard, which implements the canActivate interface. The class will be annotated with injectable decorator, but I won't register it in the app module. Again, I will use it directly inside the useGuard's decorators. Then, I will inject the reflector class through the class constructor. The reflector is NestJs class giving us a reflection capabilities. Then I will use the reflectors method called getAll and override. Here I have to pass the key of the metadata property we want to read, as well as the context from where it should get the information. In our case, it's a handlers method. Then we can implement the actual authorization. So if there is no role found, we will allow for the access. This means that the decorator was used, but no specific role was required. Then we will unwrap the users from the context from the HTTP request. We can do this because the passportJs added the user to the request object. Finally, we can compare the user's role with expected role. If the method returns false, then the framework will return the 403 status and the endpoint won't be reached. That's the whole logic of the guard. Now we can test it in practice. Let's open the recipe controller file. Above the delete recipe method, we have to add the role decorator and pass to it the admin role. Then, inside the use guards decorator, I will add role guard at the second position. It's super important to keep it in the right order. The authorization has to be fired after the authentication step. Let's save the file and let's try to delete the recipe. Firstly, we have to grab the authorization token and add it to the authorization header inside the delete endpoint. When I click send button, there is 403 status, forbidden resource. That means we cannot delete the recipe. Great, that's what we wanted too. Currently, we don't have an admin yet. Let's create a new user. I will change the email a little and click send. Now we have a new user, but it has only a user role. I will open a database and I will update the role there. So now we have the administrator user ready to use. We have to log in first, then we have to grab the token for the administrator. And finally, we are able to delete the recipe. Great! So that's it, what I have prepared for today's lesson. That's a lot of information, so if you don't get something, please rewatch Unclear Fragment or ask me any question in the comments below. In the next lesson, we will be talking about error handling in the NestJs apps. Meanwhile, thank you for the watching and see you next time.